Okay, just let me give you a quick context like what we'll be doing in this video. So this is the ongoing part of getting information related to the operating system and the kernel. In the previous two video we have talked about the different operating system like Linux, Unix and BSD, and in the second video we talk about the distribution or distro. And for this video my focus will be on the architecture. Let's just talk about the architecture. So what is architecture? We need to study that a little bit because this will help us when we are compiling exploit. We need to be careful with the architecture. Are we going with the 32-bit or 64-bit, and based on what we decide we are going with 32 or 64. So I need to go here and see we have the architecture. So when people say architecture computing, they just mean how CPU or processor is designed and how it works. So just giving some basic detail like CPU is a kind of brain and it does calculation and instruction, but not all CPU are designed the same way. Different CPUs speak different languages at the hardware level. So all this mean is the architecture just mean that different CPUs do the calculation instruction, but not all of the CPUs are the same, and CPU actually speak kind of different language, you could say that, at hardware level. And since you will be running software on that CPU, what you will do is you need to figure out what that specific language that CPU speak in order to the software to be working on that CPU. So that's what actually architecture mean. So we have two type of language, I guess. One is the bit 32 and another is bit 64. Over here you can see the CPU process data in parts or chunk, and that chunk is what we call the 32-bit or 64-bit. So it also gave us example. Imagine you are moving boxes from one room to another, and you can carry either one box or four boxes at a time. So you are basically doing the same job like transferring the boxes from one room to another, but taking more than one box like four boxes is like faster and efficient. But for that you need to be strong, because if you are like kid or small person or like weak person and the boxes are heavy, you will not be able to carry those four boxes at once. So you have to be stronger. Similarly 32-bit is like the old one and 64 is the newer version. I don't know, but I think like that because it just carry less data, less chunk at a time, and this carries more. So it's like a modern version or a stronger version. Imagine this is like a kid born and he can only move one box at a time because he's small guy and he cannot take actually more than one box. And this is like older stronger guy, he can actually take four boxes. So for example, you write some code for a software or exploit and you wanted to run it on a system that is 32-bit, that has the 32-bit architecture, but for some reason, either mistakenly or for some other reason, you just compile it for the 64-bit architecture type computer or CPU. So you see right here, you are trying to run a software that is compiled for 64-bit, but you are trying to run it on a 32-bit, so it's like both different language, so it won't run actually. I need to just a little bit clarify what the compile mean. Can you just explain what does the compile mean over here? I'm going to copy this. Okay, delete, do that. I'm going to discuss this. So we have a different type of the architecture name. If you remember earlier I said we have this is only the 64-bit and 32-bit. I will just explain that in a moment. Okay, so compiling is the process of translating human readable code into CPU language. So when programmer write code like this, it can only, because it's like the ABC stuff and only human can understand it, a programmer, but the CPU cannot because it only understands the 0 and 1. So to make the CPU able to read this, we compile it, and that compilation, what the compilation does, it convert this code into zeros and one. Okay, and now with the name I was telling you, we have these names. One is this, and we already talked about this. Now we have the x86, so it's equivalent to the 32-bit, and if we add the 86-64, it's basically the 64-bit version for the Intel chips, and this is what modern computer uses. That's what I told you, like a strong guy and weak guy. And for the AMD chips, I guess it's the same x86 underscore 64. I think for 32 it will be like AMD 32, and this is another one equivalent to the 32-bit x86, that we rarely see nowadays, and we have another one, the ARM. So it's for another chip completely designed for that, and it uses in phone, Raspberry Pi, Apple M1, M2. Let me actually find out what this ARM is. Like copy this and paste it over here. Can you just tell me about the ARM, like what specific chip it is used for? Let's just see what we going to get. Bro, it's just going a bit more technical, and bro, just explain it simply, don't go very technical. So I think it's more like relevant to the related to the battery thing, because you can see right here every tablet, laptop, modern laptop are running ARM chip, and while the Intel and AMD are mainly for desktop PCs, gaming computer, and traditional old laptops. So because they don't have, mostly these does not have the battery, and these are the old laptop, because they were all because of that they were using the other architecture. And another sentence, anything plugged into a wall where battery life does not matter as well. So can you make it more simple? Is it like battery relevant, or I don't know what you are saying? Make it simple. Yeah, it's for efficiency, and as I said, if the same ARM thing were used in desktop PCs, it will just drain the battery so fast. But since it does not have battery, they just use the Intel AMD chips. And while the other devices like tablets, phone, and MacBook, they are using the ARM chip in MacBook from 2020, and in the modern devices as well, because they are more efficient and use little fuel or battery. So basically this 64-bit and this is same as well as this, and this also I guess the same. So when we are making exploit and compiling it for a system that has 64-bit architecture, we will need to compile it as a 64-bit, and if it has ARM chip, we will need ARM exploit. I hope you get the idea of what I'm trying to say. Okay, so if you don't understand anything, let me know in the comments. I will make sure to answer you. And I think we have talked about the theory enough. Now what we will do is we will go to the Kali Linux and actually type the command that will give us information about the operating system and the kernel. So the next video will be on that. I will see you in that.